Hello. All right. So, you are probably in my classroom if you're listening to this, and I'm coming to you from the digital domain to teach the class as I am out today. Um, and I only have about 15 minutes to make this video before people come in for lunch, so I'm going to get straight to this. Mentally math. Let's get mental. Okay, so looking at this, we know that basically negative exponents are fractions. So this would actually be 1/100th. I guess it would be a good idea for the substitute teacher to pause the video for a minute and let the class kind of do some of these out ahead of me. So if we could just pause the video for a moment. Thank you. And we're back. Okay, so scientific notation. We are actually, well, this is interesting. It's division, but where it's 4 divided by 4 and 10 to the power of 8 divided by 10 to the power of 8. So that's just 1. Right? Then looking at these, well, a little bit of interesting cross-multiplicative goodness going on here. So, well, looking at this, you'd multiply them and divide by this guy. So it's essentially almost like 144 equals 144. So the answer to this would be 1 as well. Then metric conversion. So 200 centis in a meter, 200 centimeters in a meter. So it'd be 2 5/10 meters. And then fractional parts, 2/3 of, well, 12 is 8. In this case, 800. And then 1,200 reduced, well, by 1/3 is also 800. And looking in here, which number does not belong in the list? 12, 15, 19, and 21. It appears to be the one that you cannot divide by 3. Is the one that does not belong there. So 19. It's the one that does not belong. And then a nickel is how many cents less than 3 dimes and 3/4? So 3 dimes and 3/4, well, would be $1.05. So it is 100 cents less. Whoops. All right, I've got 10 minutes here. Wish me luck. We're talking about factoring algebraic equations. And I particularly might want to go a little bit fast on this one because this kind of looks like something we've done before. We want to factor this out for whatever purposes we have. Maybe some cross-canceling goodness. Maybe something else. But we want to take this monomial and break it up into its kind of individual parts. So we could almost kind of make a little factor tree out of 12 and say, well, that's 2 times, I'll go a little bigger here. We could say 2 times 6 and then 2 times 3, right? So then that ends up being 2. We're just going to use parentheses, 2 times 2 times 3. And then we just put the number of variables in individually as there are exponents for it. So a squared is a times a. B cubed is b times b times b. And just need to bring down one c. And that's it, which seems kind of reviewy to me anyway. That's good. All right, so this is a little bit more interesting, I think. So we want to factor a trinomial. And so what we want to do, so we're looking at a 6a squared times b, 4 times a times b squared plus 2 times ab. And so what we want to actually find here is our greatest common factor for all 3 of these terms. So we want to say, okay, well, what we can look at here is say, well, all of these are they're all multiples of 2. Okay. So we could say that our greatest common factor in there is 2. And they all have at least one a variable, and they all have at least one b variable. So that actually makes our greatest common factor in this trinomial 2ab. So now we just want to divide each of these terms by 2ab. So we could say this is a totally true statement. All right. We can say that these would all kind of end up sort of meaning the same thing, and then dividing each one of these, well, and this will ultimately be a thing that we are using the distributive property. We can write an equivalent statement that is still true by saying 2ab times each of these factored values will end up equaling the same statement as we started there. So we could say 2ab times, so looking at the first one, 6 divided by 2, spoilers, is 3. And then you can essentially do a little cross-canceling there, a little cross-canceling there, ends up getting us 3a. Then 4 divided by 2 is, yes, you guessed it, 2. And then using our cross-canceling goodness here, we can cross-cancel those. And we can cross-cancel that. And so then that gets us to 2b. And then, well, that can only equal one thing. That equals 1. That's a terrible one. Sorry. I'll just say that for 1. Okay, and so this would be the factored version of a trinomial. One more time, you want to find the greatest common factor of each term. And you do that by just seeing what are the common factors in there. Right? In this case, they were all multiples of 2. They all had at least one a, and they all had at least one b. So we could say 2ab for that. And then, so logically, once we divide each one and create kind of this factored version of each term has been divided by 2ab, 3a plus 2b plus 1, you can say that, well, if you multiplied each one of those by 2 times a times b, then you'll end up with the same thing that you started. But in this case, we've got something that could be useful later on if we were working on a larger equation where this would actually maybe be simplifying what we were trying to do. So this feels kind of like a piece of a larger puzzle, but it all makes sense. Okay, have fun doing your written practice. Bye-bye.